This lesson is about learning how to undo polynomial multiplication. So this process of undoing multiplication is something that is called factoring. So factoring literally is when you are trying to undo a multiplication. Now, you have been doing this for a long time. All right, for example, if I gave you, for example, the number 10, you know that there's a couple of different ways that I can represent 10. I know that it factors to 1 times 10. I know that it factors to 2 times 5. And both of those are viable answers. When we deal with polynomials, there's only one way to do things. So we need to learn this technique. All right, the two techniques that we're going to focus on for factoring today, all right, is undoing the distributive property. All right, that's known as GCF factoring. And then the second one is called factoring by grouping. All right, so bear with me on the video. We'll get through. Hopefully it'll make a lot of sense to you guys. Okay, so the first one that we want to do is this thing that we're going to refer to as GCF factoring. Now, GCF factoring specifically refers to the result of something that we got when we did the distributive property. Okay, so the first step here of GCF factoring is I want you to determine the largest common factor. Now that largest common factor we are going to refer to as the GCF, the greatest common factor. After we determine that, what we're going to do next is we're going to write, write the GCF, and then right next to the GCF we're going to put a parentheses. And what we have to figure out is what goes in that parenthesis right there. So the third step is to fill in that parenthesis. We are going to divide each monomial by the GCF. Okay, so let's take a look at an example. For example, the directions are simply going to say factor. All right, number one. Let's say that I give you a problem like this, 16x minus 40y. And I want you to factor this. The first thing I'm going to do is I'm going to look at each of the terms. I have 16x and negative 40y. I notice first that from the variables, there is nothing in common. One's got an x, one's got a y. I notice from the numbers that both of these terms are divisible by 2, but I want to look for the largest one. I notice that they're both divisible by 4. Is that the largest one? I notice that they're both divisible by 8. So that 8 is going to be what we refer to as my GCF. My GCF is 8. So now what we're going to do is we're going to take that GCF 8 and we're going to write a parentheses. I take that GCF and I divide each term by that GCF. The results that I get go in the parentheses. 16x divided by 8 would be 2x. 40x, or minus 40y I should say, divided by 8 would be minus 5y. This is known as the factorization of 16x minus 40y. A quick, easy way to check it, distribute. If you distribute it back in, you should get what you started with. All right, let's try another one. In this one, let's not only have common numbers, but let's also have common variables. So I'm going to look at each of these two terms. I notice the GCF for the numbers would be 2. They are both divisible by 2. But I also notice they both share the same variable. When you're dealing with variables that are common variables, like they both have an x, what you want to do is the GCF simply becomes the smallest degree. So because this x to the first is the smallest degree, then that's going to be my GCF. I then write down GCF times, and I'm going to divide each term by that GCF. Now, when we multiplied, we added powers. So when we divide, we're going to subtract powers. All right, I'm going to take 2 divided by 2, that gives me 1. X to the second divided by x, that gives me x to the first. And then I have 4 divided by 2, well, that gives me 2. And x divided by x, they cancel each other out. So my factorization would be 2x times 1x plus 2. And again, I can check that by distributing. All right, let's try one more. Try to make it just a little bit more complicated. Let's say for this one we have multiple terms and multiple variables. So for example, we have 4x squared y squared plus 2x squared y minus 10x y squared. Now, in this term, it's a trinomial. In this polynomial, it's a trinomial. I have to find something in common between all 3 terms. So I do the numbers first. I notice I have a 4, a 2, and a negative 10. I know that they all have a 2 in common. I look at the variable x. I notice I have x squared, and x to the first. Go with the lowest power. I know I have y squared, and y squared. Go with the lowest power. So now I'm ready to factor this, and it's going to factor to 2xy times. Now I got to do my division. Divide each by 2xy and treat each monomial separately. So 4x squared y squared divided by 2xy, that would be 2xy. The second term, I'm going to get plus 1x, and the last term, I'm going to get minus 5y. All right? So the next type of factoring that we're going to look at is something that is called factoring by grouping. All right? Grouping is actually really easy if you understand the concept of GCF factoring. Okay? So the first thing that I'm going to do for grouping here is I'm going to figure out when am I going to be looking for this. All right? You always want to look for grouping when you have 4 terms. So when you have that 4-term polynomial, I'm immediately thinking grouping. It's not going to work 100% of the time, but that's really my indicator that says, hey, let's try to group this and see if we can factor it by grouping. All right? So how do I want to group this? I want to group the first 2 and last 2 terms. Now, when I do that, I use parentheses. All right, so I group the first 2, I group the last 2. All right, step 3. I want you to think of this pattern. We're going to go GCF of the first group, GCF of the second group, and then we're going to go GCF done. All right, I know it kind of sounds a little strange right here, but you'll see as we go through some of these examples. All right, so let's see what these examples are. First of all, again, the directions are just going to say factor. All right, so for this problem, let's say that I have FG minus 5G plus 4F minus 20. All right, I have 4 terms, so the first thing I'm thinking is group the first 2, group the last 2. Now notice when I group the last 2, I included the sign of that 4F. All right, really important. All right, I look at the first term. I notice that it has a GCF of G. I divide each of the terms by G, and I'm left with F minus 5. Pretty simple. All right, when I when I factor the second one, I am trying to make that same F minus 5 show up in another parenthesis. So if I look at these two, I notice that I have a GCF of a positive 4. I divide that out of each of those terms, and I'm left with F minus 5. Now, do you notice how this F minus 5 and this F minus 5 are the same? That's actually the GCF of that line. So I'm going to write down F minus 5 and divide each term. Here's one of the terms. Here's the other term. Divide each term by F minus 5. And that leaves me with G plus 4. So those 4 terms actually created for me a binomial multiplication scenario. All right, let's take a look at another one. Let's say that we have 45xy minus 27y minus 50x plus 30. I see 4 terms and the directions are factor. First thing I'm going to do is try to group things together. All right. In the first group, I have 45xy and negative 27y. I need a common factor. Let's see, 9 goes into both of them, and y goes into both of them. So I'm pretty confident that this is going to be 9y. And when I pull that out, divide each of the terms, I get 5x minus 3. Okay, so now we need to factor the second group. But remember, we're trying to make what's left in the parenthesis 5x minus 3. I see there's a plus in front of that 30. So I know I'm going to have to factor a negative something out. I know that between negative 50 and positive 30, negative 10 would be a common factor. When I divide that out of each of those terms, I'm left with 5x minus 3. So notice once again, because those are the same, I can now do this final step of GCF. I have a GCF of 5x minus 3. I divide each term by that, and I'm left with 9y minus 10 for the other factor. Okay? I want to do 2 more examples with you guys, just so you've got some extra examples here. Hopefully you've been following along. 21xy minus 3x minus 35y plus 5. All right, group. Got to make sure you're writing things clearly. GCF, 3x. Pull it out, 7y minus 1. GCF is going to have to be a negative 5. Pull it out, 7y minus 1. GCF, 7y minus 1. What's left after you pull it out? 3x minus 5. Done. And once again, just like we saw with GCF factoring, I can multiply these binomials together, and if I factored it correctly, I should get what I originally started with. It may not necessarily be in exactly the same order, but all 4 of the terms will be there. So let's try this one more and then have you guys get started on your assignment. 27xy squared minus 18x squared y squared plus 3xy. Wait a minute, Leonhardt. There's only 3 terms there. You're right. When there's 3 terms, the first thing I want to think of is not grouping, but GCF factoring. So I'm going to think, okay, what's the GCF here? We'll do the numbers first. I have 27, negative 18, and 3. 3. I have x to the first, x to the second, x to the first. They all have an x. Pull it out. Y squared, y squared, y. Pull it out. Just one of them was in common. Divide each of the 3 terms by that. I get 9 minus 6xy plus 1. And for this problem, all that I could do was GCF factoring. Hopefully this helps. Good luck. Do your homework. Again, remember the assignment here, all right, is 16 to 38 even. All right? Have a good day.